Welcome to this eLearn Security video lesson on post flooding with Ruby. In this video, we're going to see how to write a simple Ruby script that is able to send a flood of post requests in order to insert a huge amount of comments on the Foo Radio Hack Me web resource. Hack Me is a platform that holds a collection of runnable, vulnerable web applications that we can use to learn web application security. Foo Radio is one of them, and it contains some interesting pages that we can use to test our knowledge about post requests using Ruby. Particularly, we're going to see how to perform post requests using the net HTTP library. We will also see how to handle requests and response headers in order to receive and set cookie values required to run a post flooding against pages that are available only if we have a valid login session. So let's start the Foo Radio Hack Me sandbox. The Hack Me platform is allocating the sandbox, and it may require a little bit of time. Now the sandbox is ready. This is our target web application, Foo Radio. As we can see in the program's web pages, we have some user comments. But we can also see that in order to post a comment, a login is required. So let's create a new account using the registration page. Let's move to the login page and then into the registration page. We want to create an eLearn security account with the username and password equal to ELS. Now that we have a valid account, let's log in to Foo Radio. Moving to the program's page, we can see that we are now able to post a comment in one of the sections of the page. Let's try to insert a very simple comment. Seems that the comment has been added. As we can see in the program page here, this is our comment in the AC/DC section. Let's now suppose that we want to attack this web page by adding a lot of comments. Obviously, we do not want to manually write each comment using the browser. Since there is not any human detection like CAPTCHA, it is easy to develop a script to perform the post flooding for us. We're going to use the pry interpreter before writing the actual script code. The interpreter helps the development of our script because we can immediately see the results as we write our code, avoiding a lot of errors along the way. We suggest that you use the interpreter also if you're going to develop a command line tool. In this case, since a comment can be posted only if you are a logged in user, our tool requires us to use the session ID to use a logged in session. Otherwise, the Foo Radio server will not accept the comments. Therefore, we may follow two strategies. We can write a tool that takes as input a valid session ID and then uses the session to perform the post flooding. Or we can write a tool that takes as argument the username and password of a valid account, performs the login, and then uses the session ID received to do the flooding. In this case, we have to extract the session ID using other tools such as a browser debugger. We will use the second scenario because it is more interesting. Since there is not any human detection, all can be easily done using Ruby. Before writing the tool, we want to use the interpreter to perform the login process on Foo Radio. After a successful login, we should receive a valid session ID that we can then use in all the post comment requests. Let's start by opening the pry interpreter. The first thing to do is to require the net HTTP library. Let's create the login URI that obviously is the Foo Radio login page. Now we have to perform a post request, but we need to know the parameters to send with the post. So let's inspect the login form using the browser. The action of the login form is login.php web resource. Additionally, as you can see, we have to provide the user and the pass parameters that are the fields of the login form. So let's use the net HTTP post_form class method to perform a login request using the account we have created before. So we will use ELS as the user and pass parameters. As you can see, we have an HTTP response object. Note that the net HTTP post_form methods perform a post request, and its result is a net HTTP response object that stores all the response information. For our purpose, we are interested only in the response header. So inspecting the response headers with the toHash method, we can see that there is a set cookie header with the PHP session ID. This identifies the login session. We must use this session ID to post a comment on the Foo Radio Programs page. So let's try to post a comment. Of course, we need to know the parameters required for the post request. Let's inspect the comment form using the browser, but we have to log in to see the comment form. As you can see in this case, the form action is sendMessage_confirmation.php, while the input parameter name identifies the object of the comment. The comment parameter specifies the content of the comment. Finally, the cat parameter identifies where to post the comment. In this case, cat is equal to 1. This is the AC/DC section. As you can see, the Led Zeppelin section has the cat parameter equal to 2. So let's send a comment to the AC/DC section, the one with cat of equal to 1. Since now we have to set the cookie header of the post request, we need to use a net HTTP instance. The net HTTP instance requires a target address, the root of the Foo Radio Hack Me. The session ID, as we've seen, is stored in the set header of the login process. We want to send a simple comment to the AC/DC section, so our form content will be as follows. Remember that we need to encode the form. Now we can use the post method with the suitable parameters required to post a comment. So the target is sendMessage_confirmation.php, the form action we saw previously. Encoded parameters are stored in the variable named enc_params. And finally, it is very important to specify the cookie header containing the login session ID. Otherwise, the Foo Radio server will not accept our comment. Let's see now if our comment has been posted using the browser. As we can see, we have the comment exactly in the AC/DC section. As a quick example, let's try to insert a comment on another section, for example, the Led Zeppelin category. So thanks to the interpreter, we have a way to log in to Foo Radio and then post comments on the program's web pages. We can now write a script that performs a post flooding using the strategy we saw with the pry interpreter. Let's create the flood script on our desktop. The arguments of the script can be the username and password required to log in. Of course, all the other parameters, such as the object or the text or the section of the comments, can be fixed or taken as input. We want a simple script, so we will set them hard-coded in the script. To get started, we'll need the net HTTP library, so let's require it. The target URI is the first parameter of the script, while username and password are the second and third arguments. Let's create the net HTTP instance that we are going to use for all the requests. The first thing to do is the login process. So let's create and encode the login form parameters, user and password. Let's now send the login post request to the login.php web resource. The login request obviously contains our user and password parameters. We know from the interpreter that the response object contains the set cookie header that stores the PHP session ID, which identifies the login session just created. So let's extract the session ID. Now we are able to perform the flooding. Let's create and encode the flooding request parameters. Remember that a comment has a name field storing the object of the comment. Then it also has a comment parameter that stores the real comment text. And finally, it has a cat parameter that stores the section of the comment in the program's foo radio page. In this case, 1 is the AC/DC section. The last thing to do is to create the loop. Let's create a loop for 50 comments. You can decide to parameterize this value too, taking it as an argument of the script. The body of each statement has to contain the post method, but pay attention. Each post request must contain the cookie header that stores the PHP session ID that identifies our logged in session. Otherwise, the comment will not be accepted by foo radio. Additionally, you can randomize the comments fields such as the object or the text of the comment, but for testing purposes, our script is enough. So let's execute it and see what happens. The first argument is target, obviously the foo radio sandbox. The second and third are username and password. The script may require some time because it has to send the 50 requests. Obviously, we can improve the time execution using, for example, persistent connections. This can be achieved by using the start method provided by the net_http class. We can also write a multi-threaded script that is able to perform multiple requests at the same time. Here we see the script ends without errors. Let's use the browser to see what happened. As you can see in the AC/DC section of the foo radio program, we have a lot of comments coming from our script. Our flooding worked, so the foo radio application is indeed vulnerable to robot attacks such as post flooding. Obviously, finding such a vulnerability is an indication of bad web development and design, and with further investigation, we could probably find other vulnerabilities as well. Also note that the login form is vulnerable to robot attacks in addition. These attacks can be used to brute force a foo radio account. In other words, the post flooding is not the only interesting thing you can do using the foo radio hack me. You can test your skills with a lot of different tasks. You can also use other hack me's available on the platform. It is all legal and designed for you to practice and refine your pen testing skills. Thank you for joining us.